A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You know, Herman, I was looking at my browser tabs this morning, which is always a dangerous way to start the day, and I realized something. A year ago, every second post on my feed was about a new deep research framework. We had this explosion of specialized tools that promised to go out, scour the web, verify facts, and hand you a thesis-level report. Now? It feels like everyone is pivoted to talking about general agent swarms and orchestrators. It's like the specialized research tool is becoming the forgotten middle child of the AI world.
It is a fascinating shift in the collective consciousness of the dev community, Corn. And it is timely because today's prompt from Daniel is exactly about this. The unique architecture of deep research products and why they seem to be fading in popularity compared to general-purpose orchestrators. It is actually a bit of a tragedy because, as we will get into, the performance gap between a specialized research framework and a jack-of-all-trades agent is massive.
Well, before we dive into why they are being ignored, we should probably define what we are actually talking about. Because to a casual observer, an AI that does research sounds like any other agent. You ask it a question, it browses the web, it gives an answer. By the way, speaking of things that give answers, today's episode is powered by Google Gemini 3 Flash. It is the engine under the hood for our script today.
Herman Poppleberry here, and I am ready to get pedantic about definitions, Corn. When we talk about deep research products, think of things like Perplexity Sonar's research mode or the frameworks featured on the Deep Research Bench. We are talking about systems with a very specific iterative architecture. A general-purpose orchestrator, like something you'd build in LangGraph or Crew AI, is usually designed for task delegation. You give it a goal, it breaks it into subtasks, and it assigns them to workers. It is a tree structure. Deep research, however, is more of a recursive loop with a heavy emphasis on verification and evidence accumulation.
So, a general orchestrator is like a manager at a construction site. You go dig the hole. You go get the bricks. Whereas a deep research product is more like, what? A persistent detective who won't stop until they find the smoking gun.
That is actually a decent way to put it. The core difference is the research graph versus the task tree. In a general orchestrator, once a subagent completes a task, say, find the population of Tokyo, the result is passed back up and the orchestrator moves to the next branch. In a deep research framework, the system is constantly maintaining a structured representation of hypotheses and confidence scores. If it finds a piece of evidence that contradicts a previous finding, it doesn't just move on. It triggers a reevaluation of the entire research path.
I think that is where the nuance gets lost. People think agentic is a binary state. Either it's an agent or it isn't. But what you are saying is that deep research tools are built with a specific epistemic humility in mind. They don't trust the first thing they find.
Precisely well, I should say, that is exactly the mechanism at play. If you look at the Deep Research Bench, that is the project at deepresearchbench.github.io, they've actually quantified this. Specialized research frameworks outperform general orchestrators on verification tasks by 40 to 60%. That is not a small margin. That is the difference between an AI that hallucinations, a plausible-sounding lie, and one that actually finds the primary source.
40 to 60%? That is huge. If I told you a car was 60% more likely to get you to your destination without exploding, you'd buy that car. So why are we seeing a decline in the hype? Is it just that general orchestrators are easier to build with?
That is a big part of it. There is a massive ecosystem momentum behind general orchestrators. If you are a developer, learning the syntax for a tool that can do research, write code, manage your calendar, and order pizza feels like a better investment of your time than learning a specialized research harness. But the trade-off is that the general tool lacks the domain-specific optimization required for high-fidelity research.
It's the good enough trap. Most people ask an AI a question. It gives a semi-accurate answer with a few links, and they say, "Cool, that's research." They don't realize they're missing the depth that a tool like Perplexity Sonar provides. I've noticed with Sonar's research mode, it will keep going for 50 or 60 queries sometimes. It has this incredible source provenance that it maintains throughout the entire chain.
And that is a perfect technical example, corn. Most general agents start to lose context or drift after 10 or 15 steps. The context window gets cluttered with irrelevant search results, or the agent loses track of the original query's intent. Deep research products use something called evidence accumulation. Instead of just passing raw text back and forth, they extract specific claims and map them to a central knowledge graph.
Okay, let's pull back the curtain on that. How does evidence accumulation actually look under the hood? Because if I'm an engineer listening to this, I want to know how to implement that in my own stack.
It usually involves a multi-stage pipeline. First, you have the query expansion phase. You don't just search for the user's prompt, you generate 5 to 10 divergent search queries to cover different angles. Then, as the search results come in, you don't just feed them to the LLM. You use a scraper summarizer agent to extract atomic facts. Each fact is tagged with a source URL, a timestamp, and a confidence score based on the site's reputation.
So it's like building a mini database on the fly for every single prompt.
Yes. And then the synthesizer agent looks at that database and identifies gaps. If it sees a claim that says Company X was founded in 1998, but another source says 1999, the system automatically generates a targeted query to resolve that specific conflict. That conflict resolution loop is what general orchestrators almost always lack. They just pick the one that appeared first or the one that sounds more confident.
That explains why my lane graph experiments always end up in a circular loop of mediocrity. It's just doing the tasks, without actually understanding the mission. It's like an intern who follows instructions perfectly, but doesn't have the common sense to realize the instructions lead to a cliff.
It is a classic problem of local versus global optimization. The subagent is locally optimized to find a search result. The deep research framework is globally optimized for truth-seeking. This is why even in the January 26 update to the Deep Research Bench, we saw that specialized frameworks are still the kings of verification accuracy. They are designed to be skeptical.
I love the idea of a skeptical AI. Usually, they are so eager to please. Yes, Corn, I would love to tell you why the moon is made of green cheese. A deep research tool should ideally say, "Hold on, I found 14 sources saying it's basaltic rock, and only one weird blog post about the cheese."
And that brings us to the research bench itself. It is such a valuable resource because it forces these models to handle long-tail knowledge things that aren't in their training data or things that require synthesizing information from 3 different PDF white papers. When you look at the leaderboard, the specialized SaaS products and the open source research harnesses are consistently at the top, while the base models and simple agent wrappers are at the bottom.
We should talk about these harnesses. Because I've seen projects where they try to take LangChain or something similar and bolt on a research layer. Does that actually bridge the gap, or is it just a fancy coat of paint?
It is a bit of both. A research harness like the ones provided by some of the open source projects on GitHub attempts to standardize the evaluation of research agents. It provides a set of complex, multi-step questions and a way to grade the output based on accuracy and source citation. However, simply using a harness doesn't magically give your agent a research-optimized architecture. You still need that internal state management, the research graph we talked about.
It feels like we're at a crossroads. On one hand, you have the convenience of general-purpose agents. On the other, you have the raw power of specialized research. If the specialized tools are fading in popularity, does that mean we're collectively deciding that accuracy is less important than ease of use? Or is it just a temporary dip while the general tools try to absorb these features?
I suspect it is the latter. We saw this with specialized coding assistants a few years ago. Everyone had a niche tool, then the big LLMs got better at coding, and the niche tools had to evolve or die. But research is different because it's an open loop problem. You're interacting with the messy, ever-changing real world, the internet. That requires a level of engineering around the model that a base model, no matter how smart, can't handle alone.
Right, because the model itself doesn't have a browser. It doesn't know how to navigate a paywall or handle a 4004 error, or realize that a website is just an AI-generated content farm. You need that specialized middleware to filter the noise.
And there I go, using the forbidden word. I meant to say that is exactly why the architecture matters more than the model size in many cases. You can have a 30 billion parameter model like GLM 4.7 Flash, which Z.AI released recently, and it might outperform a much larger model on agent benchmarks because it's been specifically tuned for tool calling and long context reasoning. But if you put it in a poorly designed research loop, it will still fail.
I think people underestimate the engineering part of AI engineering. They think it's all about the prompt. But what you're describing with Perplexity, or these specialized frameworks, is a massive amount of infrastructure. It's about managing state, handling rate limits, deduplicating search results, and verifying citations. It's a software engineering challenge, not just a vibes challenge.
That is a great way to put it. The vibes era of AI is coming to an end. If you want to build professional-grade research tools, you have to care about the plumbing. One of the second-order effects of this fading popularity is that we might see a hollowing out of the middle market. You'll have the giant general-purpose chatbots for casual use, and then you'll have highly specialized, expensive enterprise research tools for law firms, medical researchers, and analysts. The indie research tool might get squeezed out.
Which is a shame, because that is where the most innovation happens. I mean, look at some of the open source implementations on GitHub. People are coming up with wild ways to do recursive summarization or multi-perspective synthesis that the big players eventually adopt. If the developer interest shifts entirely to general orchestrators, we might lose that specialized R&D.
I think we should also touch on the interruption problem that we've talked about in the past, because it's very relevant here. In a general orchestrator, if you interrupt a task, the whole tree often collapses. In a deep research framework with a structured graph, you can theoretically pause, add a new constraint like only look at peer-reviewed journals, and the system can prune its existing graph and keep going. That kind of nonlinear research is incredibly hard to do with a standard task delegation agent.
It's the difference between a conversation and a command line script. A research tool should be a partner you can steer, not a black box you fire and forget. I've had moments where I'm using a research agent and I see it going down a rabbit hole I don't care about. With a specialized tool, I can usually nudge it back on track. With a general agent, I usually just have to kill the process and start over.
And that is a huge waste of compute. Think about the tokens being burned every time you start over because your general agent couldn't handle a mid-task correction. This is where the efficiency of specialized architectures really shines. They are designed for the long haul.
Let's talk about the practical side for a second. If I'm an engineer at a startup and my boss tells me, "Corn, we need to build a feature that researches market trends for our users," what is the move? Do I reach for a lane graph because it's what everyone is talking about? Or do I dig into the deep research bench and find a specialized framework?
My recommendation would be to start by looking at the specialized frameworks to understand the patterns of success. Even if you end up building on top of a general orchestrator for the sake of ecosystem compatibility, you should be porting over the mechanisms from the deep research world. Implement your own verification loops. Build a persistent evidence graph. Don't just trust the subagent's final answer.
So, steal the soul of the specialized tool and put it into the body of the general orchestrator. I like it. It's very Frankenstein. But it brings up a good point. Is the fading popularity actually just a sign of maturity? Maybe these specialized techniques are just becoming standard features that we expect every agent to have eventually.
That is the optimistic view. It's the absorption theory. But I worry that in the rush to make everything general purpose, we are losing the edge cases where the real truth lives. Research isn't just about finding the most common answer, it's often about finding the one obscure fact that changes everything. General purpose models are trained to be helpful, which often translates to telling you what most people think. Specialized research tools are built to be accurate, which sometimes means telling you things you didn't want to hear.
Helpful versus accurate. That is a classic tension. It's like the difference between a friend who tells you what you want to hear and a lawyer who tells you the truth so you don't go to jail. We need more lawyer AIs in the research space.
And that is why projects like the Deep Research Bench are so critical. They provide an objective yardstick. If we see the scores on that bench start to stagnate while general purpose chat scores keep rising, it's a clear signal that we are prioritizing the wrong things in our agent architectures.
You mentioned Perplexity Sonar earlier. I think they are one of the few big players who have doubled down on the research, identity, rather than trying to be everything to everyone. When you use their research mode, you can actually see it thinking. You see the queries it's generating, the sources it's discarding. It's very transparent.
Transparency is a huge part of the deep research architecture. Because the system is maintaining that evidence graph, it can show its work in a way that a black box agent can't. It can say, I am 70% sure about this claim because of these three sources, but this fourth source contradicts it. That epistemic transparency is what builds trust with the professional user.
It also makes it much easier to debug. If the AI gets something wrong, I can see exactly where the chain of reasoning broke. Oh, it trusted this satirical news site as a real source. I can fix that by blacklisting that domain. If a general agent just spits out a paragraph, I have no idea where it got its information.
This actually connects to a broader trend in AI that researchers call System 2 thinking. It is the idea of moving from fast, intuitive, next token prediction to slow, deliberate, multi-step reasoning. Deep research frameworks were essentially the first System 2 AI products. They were doing thinking before we had models like O1 or the newer reasoning-heavy versions of Gemini.
So they were ahead of their time, and now that the base models are catching up, people think they don't need the specialized frameworks anymore. But your point is that even a reasoning model still needs the right tools and loops to interact with the real world effectively.
A genius in a dark room is still limited by what is in their own head. A deep research framework is like giving that genius a library, a high-speed internet connection, and a team of fact-checkers. The reasoning happens at the orchestrator level, not just the model level.
I think this is a good moment to pivot to the why of the fading popularity. We've talked about ease of use and ecosystem momentum, but is there a business reason? Is it just harder to monetize a specialized research tool compared to a do-everything assistant?
There is definitely a higher cost of goods sold for deep research. When you are running 50 queries and processing hundreds of search results for a single user prompt, your compute costs are an order of magnitude higher than a simple chat interaction. For a SaaS company, that is a tough pill to swallow unless you are charging a premium. Perplexity can do it because that is their entire brand, but for a general purpose provider, deep research is a feature that burns through their margins.
So it's the classic infinite scroll problem. The more research the AI does, the more money the company loses. That might explain why some research modes in other products feel a bit nerfed. They stop after 3 or 4 searches because they don't want to pay for the 50th search.
It is a massive incentive misalignment. If you are building your own tool, however, you can decide where that balance lies, and this is where the open source frameworks are so important. They let you run those high token count research loops on your own API keys, so you are only limited by your own budget and patience.
I've seen some interesting work with hybrid architectures too, like the OMO hybrid models that i2 released recently. They combine transformer attention with linear recurrent layers. While that is a model-level innovation, it hints at a future where the architecture itself is more efficient at holding on to long-term context during a research task.
That is a very technical but relevant point, Korn. If we can make models that are natively better at state management, some of the complexity of the research framework might move into the model itself. But for now, the heavy lifting is still happening in the orchestration layer.
So, looking ahead to the rest of 26, do you think we're going to see a renaissance of specialized research tools? Or are we just going to keep talking about swarms and orchestrators until the next big thing comes along?
I think we will see a specialization within the swarm. Instead of one giant research framework, we will have specialized researcher agents that you could drop into a general orchestrator. But those researcher agents will need to be built using the principles we talked about today: verification loops, evidence graphs, and source provenance. The knowledge won't disappear, it will just be repackaged.
Like research as a service for your agent swarm. Hey Landgraf, go hire the Perplexity subagent to do the deep dive, then give the results to the coder agent.
That is the most likely architectural path. It solves the flexibility versus specialization trade-off by making specialization a modular component.
Well, this has been a deep dive in itself. I feel like I need to go home and apologize to my specialized research tools for neglecting them. They were doing the hard work while I was distracted by the flashy new orchestrators.
They are the unsung heroes of the AI world, Corn. If you care about truth, you have to care about the boring stuff like verification and evidence accumulation.
Alright, let's wrap this up with some practical takeaways for the people who haven't fallen asleep yet. First and foremost, if you are building something where accuracy actually matters, don't just assume a general agent can handle it. Check out the deep research bench. See what is actually winning on verification tasks.
Second, if you are using a tool like Perplexity Sonar, take a moment to look at the thinking process. Understand why it is doing those 50 queries. Those are the patterns you want to emulate in your own systems. And finally, don't be afraid of compute-heavy loops if the goal is high-fidelity research. Sometimes the most expensive answer is the only one worth having.
The most expensive answer is the only one worth having. I'm going to put that on a t-shirt and see if my wife lets me wear it. Probably not.
Probably not.
Big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a huge thank you to Modal for providing the GPU credits that make this whole operation possible. If you need a serverless GPU platform that can actually handle these heavy research workloads, Modal is the place to be.
This has been My Weird Prompts. If you found this useful, or even if you just enjoyed hearing a sloth and a donkey talk about epistemic humility, please leave us a review on Apple Podcasts or Spotify. It actually helps more than you'd think.
You can find us at myweirdprompts.com for all the show notes and the full archive. Or just search for us on Telegram to get notified when we drop a new episode.
Thanks for listening. We will catch you in the next one.
Stay skeptical, everyone. Bye. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from sloth